Looking at linear inequalities. So far, we know that if you have an inequality, that you can add the same number to both sides. That's perfect. And this remains the same. So we looked at this in, it's a video called Basic Inequalities. We looked at the fact that you could also subtract the same amount from both sides and the inequality sign would stay the same. We looked at multiplying both sides by a positive number. The inequality will stay the same. But if we multiply both sides by a minus number, in the next line, I'm going to have to change the sign of the inequality in order for the question or the statement to remain true. So keeping an eye out for that. In these questions, we're going to look at solving the following inequality. And I'll probably just plot my answers on a number line. So here I just need to clean up the left. And I have a choice now. I can try and isolate my x's on the left or on the right. I'm going to go for the right this time. So I'm going to subtract 2x from both sides. And that leaves me with minus 2 there and a 2x there. I'm going to divide both sides by 2. And I'm allowed to multiply or divide both sides by a positive number and the sign will remain the same. Okay, so I need to be able to read from left to right or right to left. So minus 1 is less than x, or if I'm reading from right to left, x is greater than minus 1. So if I was to plot that in a number line, and if x is an element of z, what's the first integer that's greater than minus 1? Well, it's 0. And the next integer is 1, 2, 3, and then I draw in my arrow. If I took another question, let's look at maybe so again, solving it, and x is an element of n, and I'll probably graph my answer on a number line. I'm going to clean up the left. I'm going to clean up the right, so that gives me 6 minus 2x minus a 3. That gives me 3 minus 2x. This time I'm going to try and isolate my x's on the left-hand side just to do it differently. And I end up, so I'm going to add 2x to both sides, which leaves me with 6 minus 2x greater than 3. I'm going to subtract 6 from both sides, which leaves me with minus 2x is greater than minus 3. Yep. So now I'm going to multiply both sides by a minus 1. But if I multiply by a minus number, this sign is going to have to change. So if I multiply both sides by a minus 1, I end up with a 2x is less than minus 3 times minus 1 is 3. And I divide both sides by 2. X is less than 3 over 2, or 1.5. So what are my natural numbers less than 1.5? Just 1. So that's my only answer. And if I plot it on the number line, it would look like that. You could do compound inequalities, or inequalities with fractions. I'll look at just one fraction one first. So I'm going to multiply the left by an 8 and the right by an 8. So if I multiply 8 by this fraction and 8 by this fraction, I'll end up with 8 times 3x minus 2 over 8 minus 8 times x minus 1 over 2, and 8 times 0 is 0. So then that simplifies. And I end up with 3x minus 2. There's loads of ways to do this. You could have not done this first of all. You could have started off and tried to get a common denominator on the left. I've just decided to multiply both sides by 8. Here, it's an 8 over 1. So 8 is made up of 2 times 4, so that will go in there 4 times. And so I end up with 3x minus 2 minus 4x plus 4 less than 0. So that gives you minus 1x plus 2 less than 0. Again, you've just to decide, do I isolate my x's on the left or the right? I'm going to leave my x's on the left, so it means I'm going to subtract the 2 from both sides. I end up with minus 1x is less than minus 2. And I multiply both sides by a minus 1. When I do that, that sign has to change. I end up with 1x is greater than 2. And you can just plot that on your number line. What are my integers greater than 2? Now, if that said x is an element of R, well, what's the first real number greater than 2? Well, it's just here, really quickly after 2 is 2.000000001. I don't know, there's obviously smaller than that. But every real number after it is allowed. So how do I show that I want to start on 2, but it's not equal to 2? I'm going to put an empty circle there. If that had a greater than or equal to sign, I'd fill in that circle because the 2 is allowed. But in this situation, now, this is if I was graphing this. If x is an element of R, this is what this question would look like. The actual question said x is an element of z, so it would just be what's the first integer greater than 2? Well, 3, 4, and so on. So that would be my solution, my number line, if the question said x is an element of z. This will be my solution if x is an element of R, if it's allowed to be any real number that I know of. And if we just look at a compound one now, let's go for 3 greater than. So here, I'm just going to add 2, but if I add 2 to one side, I have to add it to every side. And I end up with x, 5 there, and a minus 3 there. And it's just about being able to read this. X must be less than 5, but it has to be greater than minus 3. So any number less than or equal to 5, so less than or equal to 5. So it can be equal to 5, and it can be any real number less than 5. But it has to be greater than minus 3. So it's any number that's less than or equal to 5, any real number in this situation, real number. But it has to be greater than minus 3. So can it be equal to minus 3? No, but it can go right up to it. And the way that I show this is, I'm going to put an empty circle there. So I can put a full circle in here, filled in, because it's allowed to be equal to 5. But I have to put the empty one there when it's a real number, because it's not actually allowed to be equal to minus 3, but it could be any real number right up until that point.